Good afternoon, everyone. I'm Dr. Lockyarker, I'm Director of the Swan Medicine Education Center. Thank you very much for joining us today for the webinar entitled PRRS 144 Incidence and Response, presented by the Swan Health Information Center in collaboration with the American Association of Swan Veterinarians as part of SHIC's mission to address emerging diseases. The information presented today will include objective evidence, case observations, and anecdotal information. The goal is to create a snapshot of where we are currently on this issue in a timely manner and facilitate the awareness and dialogue that will improve the recognition and management of this issue. We got a great panel of experts with experience dealing with PRRS 144 from a variety of viewpoints, and we will reserve time at the end to answer questions. I'd like to thank the speakers for their participation and all of you for joining the webinar. And I'll now turn it over to our moderator, Kristen Skolin.
Good afternoon, and thank you for attending. I'm Kristen Skolin, Program Coordinator with the Swine Medicine Education Center. Just as a reminder, prior to starting the webinar, please confirm your computer and phone audio are muted. Also, if you have a question to ask, please use the Q&A button to type your question and we'll read it aloud for all attendees to hear and for the speaker to answer. Today's presenters will include Dr. Giovanni Trevisan, Dr. Mariana Kikuchi, Dr. Paul Yeski, and Dr. Daryl Holtkamp. They will be covering topics ranging from PRRS 144 detection, incidences, and outbreak investigations. We'll begin with the webinar with Dr. Giovanni Trevisan, a postdoc trainee at Iowa State University College of Veterinary Medicine and the Swine Disease Reporting System Coordinator. Dr. Trevisan received his DVM equivalent in Brazil in 2009 and his PhD in Population Sciences and Animal Health at Iowa State University College of Veterinary Medicine in 2020. The title of his presentation is Swine Disease Reporting System Update on PRRS 144 Lineage 1C Variant. Giovanni, I'm going to turn it over to you.
Thank you, Chris, for the update, and thank you for the opportunity to be here presenting for you today. So, as you mentioned, I'm going to give you an update on the SDRS PRRS virus 144 lineage 1C variant strains. Next, please. So for who is not aware of what is the Swine Disease Reporting System, it's a project that collects and receives data from different VDLs, that's Iowa State University, University of Minnesota, South Dakota, and Kansas, and reports this data on a standard format and produces monthly reports and online dashboards. So we have information for PCR detection for PRRS virus and the other agents, and PRRS RR5 sequencing from the participant VDLs. This is a Swine Health Information Center funded project. Next, please. So just to give a brief overview from where the samples came from for this project, we have here a map from the US that presents the timeline when PRRS virus has been detected in different states using this database. And we can see that PRRS virus has been spread across basically all over the United States already. Next, please. So one thing that we do with this data is we aggregate the results and we do apply monitoring algorithms to that. So here we have a chart that presents the PRRS virus detection in terms of percentage of positive results by year and week on the x-axis and percentage of positive results in the y-axis. We do use historical data, and here we can see 2008, 2019 being used to forecast the expected detection for the years of 2020, and that is the forecast for 2021. The yellow arrows present the time of the year where PRRS virus detection has been above the expected, and we can see that most at the end of 2020 and now during end of April and May of 2021, detection of this agent was above expected. Next, please. So bear with me, it's a busy chart, but here we have the CT values obtained on those samples that are tested for PRRS virus. And it's organized by year and month. And the lines, the red, blue, green line presents the CT value information, and the black line with this squares present the percentage of positive results. This yellow circle is positioned over April to June of 2020, because at this period of the year, we had a decrease in the CT values from samples tested that were coming from animal farms classified as win-to-market age category. So this decrease in the CT values observed on these sample types is not expected for this time of the year and was above any other period of the timeline that we see here. At the same time, percentage of positive results for PRRS values went up. So if we have lower CT values detected in the samples, that means that we are having a higher viral load concentration, and it's very likely that these animals are shedding more virus to the environment and may be playing an important role on the epidemiological situation for this particular strain. This decrease in CT values was associated with higher sequencing of these new PRRS virus 144 lineage 1C variant strain. Next, please. So if we look for this chart here, it's the percentage of positive results on PCR detection for different age categories. And if you look at the top curve that presents the win-to-market, and we can see that there is a higher detection from this type of, from these samples coming from this type of farm. And at the very end of June and the first few weeks of July, we start to see a decrease in detection of PRRS virus from these samples. So that may be a very good information. On the other side, the overall percentage of positive results that is demonstrated by this black line with triangle shapes is still similar in July when compared with June. And a lower decrease in detection from adult sow farm has been observed. So that means we may entering the period of the year that is the summertime when we expect lower detection for this for PRRS virus. At the same time, if you look for this line of detection for adult win-to-market age category, year over year, we see a preceding increase in detection of PRRS virus on win-to-market age categories, preceding an increased detection for adult sow farms. So as we move through the fall, that may be a very important thing to keep in mind if we start to see this increased detection. Next, please. So when we think about PRRS virus, you can put out the lines here, Chris. When we use PRRS virus, we do sequencing, and from that we can do some genotype information that can be RFLP patterns or can be lineages. And when we think about RFLP patterns, we need to keep in mind that it was created to differentiate wild type strains from a vaccine virus strain, and is not very good to differentiate between wild types. So new proposal has been done to classify sequence according to lineages, and that is more likely to differentiate the wild type strains. Next, please. So here we have a chart that's organized by year and presents the number of sequence in the bottom, and in the middle, the chart that is colors and numbers online on the top. The numbers represents the RFLP patterns, and you can see that in 2021, there is an error that is pointing for a large increase in the proportion of the RFLP types that was detected as 144. So this is contributed by this new variant strain. Next, please. And when we plot the same information, but now using lineage classification, we can see that in 2021, lineage 1C variant is taking over, and is already the fourth most frequent detected lineage. So motivated by this new variant that was evolving, we created this tool that you can compare either RFLP or lineage, and is available online, the swine disease reporting system. And we have been releasing that this month. So you can go there and explore more about this information. Next, please. So one thing that's still being is how we compare RFLP lineage. And here we have a video on the left side, you are going to see RFLPs, and the right side lineage and comparison over time. If you look for RFLPs, the 144 and the lineage 1C was there for a longer period of time and keeps a very dynamic detection of this sequence as classified as RFLP or lineage. Most dynamic changes occur basically in 2014, when you are going to see the RFLP 174 and lineage 1A that arises and become the predominant detected for a good period of time. And the other lineage keeps dynamics there. So as I mentioned, all of this information is available on the swine disease reporting system website. And most recently, in 2020, we started to see this new lineage 1C variant strain that is started arising. And in 2021, it becomes one of the most frequent detected. And as it is classified as RFLP144, RFLP144 is the most frequent detected as well. Next. So specifically for this lineage 1C variant strain, the first detection that we do have on the SDRS database goes back to January of 2020. And all the other sequences classified with 1% similarity to our reference strains. If we look for the detection of these strains, we have kind of waves, where the first one was around May, June of last year with a couple of detection in different farms. But basically at the end of 2020, there was a large spread of this strain across different farms, mostly in Iowa, Minnesota. And now at the end of April and May was a large number of breaks of this strain affecting different farms. If you look for the states where it is most frequent detected, it's Minnesota and Iowa. But additionally to that, we have other 7 states that has been identified using this database and some sequence that came from a state that was not informed. So it's largely spread. And we are seeing during June, lowering the number of sequence for this specific strain, basically 10 sequences less than May. And it may be signaling for a decrease in this wave of detection. As I mentioned before, we are entering the period of fall and winter months in the upcoming months, sorry. And we may see another wave of spread of these agents when the weather conditions may favor the spread again. Next, please. This is just similar information, but now is organized as the total sequence by state and age category. And you can see that the most sequence were done from samples collected in Minnesota and Iowa. And we see the regional spread from other states like Nebraska, South Dakota, Missouri, Illinois, Indiana, Michigan, Wisconsin. So it has been spreading around. Next, please. When we put this sequence in a tree, and here what you are seeing is a tree from the lineage class, the OR5 sequence classified as lineage 1C or lineage 1C variant from 2018 to 2021. And you can see the tree that there is some differentiation and there is some clusters that are forming. If you look for the bottom of this tree, there is a couple of colors that shows there, and those are the lineage 1C variant strains. Next, Chris. When you give a closer look on that, here we have the tips, label tips of this tree. We can see that classifying with some open source sequence that are out there available in the PubMed. There is some cluster that is the purple one in the top, the green one a little bit in the bottom, where the sequence are clustered together. If you look for the very basic blue sequence at the bottom, that is where the first one was detected and it's clustered together. So a lot of different sequences are grouping different. So this strain is evolving and is forming different groups. Next. Now, if you remove the tips of the label tips of this tree, you can see just the branch here. And it's very clear that different groups are forming, that this virus is evolving, and we should not expect that it's going to behave the same across the farms. We may start to see some of these sequences that are going to have lower, be less aggressive in the animals as we detect them. Next, please. So the highlights is that the PRRS virus lineage 1C is still evolving over time. They are forming different clusters. This strain was most frequent detected in Iowa and Minnesota, but still being spreading across different states. And within the L1C variant strains, we are starting to see different clusters being formed. So it's a great idea to keep an eye on those and be conducting some epidemiological studies to see how that's going to be affect the animals. Next, Chris. So with that, thank you for the opportunity to be here talking, and I'm sure that you're enjoying the next phase of this seminar with this field information that's coming out.
Thank you, Dr. Trevisan, for your presentation. Our next presenter is Mariana Kikuchi, a DVM with an MPH and PhD in epidemiology. Currently, she is a researcher at the University of Minnesota, St. Paul, working with the Morrison Swine Health Monitoring Project. Her research focuses on epidemiology of emerging and infectious diseases. The title of her presentation is Occurrence of the Newly Emerged PRRS 144 Lineage 1C Variant. Dr. Kikuchi, I'm going to turn it over to you.
Thank you, Kristen. Yeah, so I would just like to start by, we're going to do this presentation showing a little bit of the work that we have been doing at the University of Minnesota, but I'd just like to start by thanking the MSHIM participating systems and practitioners for sharing all the data that we're going to see here today. Next slide, please. So I wanted to start with this slide, just highlighting why is this new variant of interest. And I think, as many of you know, we've seen several PRRS strains emerging throughout the years. The most recent one before this one was the 174s. And I think what's unusual about this particular outbreak is that we are finding highly similar viruses at the R5 level being detected in different sites within different systems that are apparently not necessarily epidemiologically related. So you can see here on the left, phylogenetic tree with all of the cases that we have identified so far. And these are color-coded by production systems. So you can see that we have several that are very close to or even identical virus being identified throughout different systems. And moreover, we still have information from the field saying that this is actually a variant that caused significant production losses in the field. So we weren't able to get too much data to put some statistics behind it, but we did conduct a smaller case control study with 11 cases and 27 controls, which were actually PRRS breaks caused by other strains. And we looked at mortality only within the first 4 weeks after detection of the break, because most of the outbreaks were still ongoing. So we were actually able to detect a higher median nursery and finishing mortality associated with this variant compared to other PRRS strains. Next slide, please. So as a case definition, we are using sequences that were at least 98% similar to any other case sequences, meaning that whenever we identify a sequence as a case, this sequence will now become an anchor to try to find other cases as well. And as of June 2021, we found a total of 259 sequences associated with this variant. You can see the epidemiological curve in the bottom, and these correspond to a total of 227 pig farms from a total of 14 production systems. As Giovanni mentioned, we had a spike in cases in December, as we can see here in the epidemiological curve. And then we had another spike in cases, or a second peak of transmission around April and May. And the second peak of transmission so far surpasses the number of cases that we have in December, which was close to where we first did the first webinar here. Next slide, please. So just going a little bit more in depth regarding those 227 sites affected from 14 production systems, we were able to identify site type for most of them. So we had a few of them that occurred in breeding herds. Most of them occurred in growing pig farms. And then for the breeding herds, because MSHIM historically monitors breeding herds, we were actually able to identify the previous PRRS status for some of these farms. And the ones that we did identify, that we saw that the majority of those either broke from a status 1 or a status 4, but we also had farms breaking from status 2 to FVI to VX and status 3. And then additionally, what we did is we tried to estimate the number of animals infected by this variant by calculating the average herd size for this type of sites and inputting the average herd size for the sites that we didn't have that information. So for breeding herds, we are estimating around 178,000 sows affected with this variant. And then for the growing pig farms, we actually have information on herd size for far less sites, because again, MSHIM has historically monitored mostly breeding herds, but by extrapolating the average herd size to the other farms, we estimate around 380,000 animals infected with this variant. Next. And then here you can see a map showing the PRRS occurrence within the US during 2020 and May 2021. You can see that most of these sites here actually represent the breeding herd that MSHIMP monitors. And in blue, we have the non-cases, meaning the sites that didn't break with PRRS during this period. And then in yellow, we have PRRS outbreaks that were not associated with this particular variant, showing that other PRRS strains are still relevant and still very important throughout this period. And then in pink, we actually have all of the cases that we have detected so far of this particular variant. So this includes both breeding and grow finishing sites. And as you can see, and that actually correlates very well with what Giovanni mentioned, we do detect this variant in other states as well. However, I would just like to point out that 98% of the cases that we detect are from Minnesota and Iowa. So that's the area that we're most focusing on. Next slide, please. So this, if you could just play the video, Kristen, this will show the number of cases per week in regards of, in relation to time and space. And we can see that we had a big increase in number of cases in December, and then again in April and May, again, corresponding to that epidemiological curve that we saw there, but also showing that most cases occur around southern Minnesota and northern Iowa. So then again, just highlighting that most cases occurred during December and May and April. Next slide, please. So after that, we decided to roughly estimate incidence. So this is very preliminary numbers. We're still fine tuning this data. But I left here on the right chart of the PRRS cumulative incidence for the year, for the past year. So the year of July 2020 to June 2021 is highlighted in red in this chart. And we can see that the year ended at 24% overall PRRS incidence. And unlike other years, we actually saw a spike in the incidence towards May, which again, we didn't observe that throughout the other years. And that's likely explained due to the occurrence of this particular variant that we are discussing here today. So if we were to calculate an incidence for the L1C144 variant that we're discussing, the overall incidence in the breeding herds would be around 11%. And then if you were to calculate incidence for Minnesota in the breeding herds, this would be 20. And in Iowa, it will be much lower at 4%. We also calculated incidence in breeding herds per system, and that ranged from 0 to 80%. Meaning that we had systems that were heavily affected by this variant, and we have systems that still, to our latest update, still hadn't detected any sequence that comprised these variants within their breeding herds. We do have whole herd data for 4 systems, and by whole herd, I mean both breeding and grow finishing sites. Again, I'm just focusing in Minnesota and Iowa. And if we were to calculate a whole herd incidence for this variant, it will be around 9%. For grow finishing only, the average would be 5% incidence, ranging from 1 to 10%. Next. And then here, just another way of showing incidence. So we are showing the standardized incidence ratio in both of these maps. So the map on the left shows us the incidence ratio standardized by density of animals. So basically it's showing the number of animals that are positive to this variant divided by the total of animals monitored within that county. And similarly on the map on the right, we have the standardized incidence ratio standardized by number of sites. So this would be more closer to our usual incidence calculation. So we have total sites affected divided by the total number of sites monitored within each county. Again, this still needs some fine tuning. We're still adjusting the numbers or making small corrections here and there, but we can see that again, most of the cases occurred in South Central Minnesota, and then Southeast Minnesota and Northeast Iowa. Next slide, please. And then just to start wrapping up my presentation, I would just like to show a few data regarding the virus itself. So you can go to the next slide, please, Kristen, and then next one. Perfect. So this is a figure that I actually showed in the last webinar. So on figure A, we are showing the phylogenetic tree of all PRRS or 5 classified as lineage 1C sequences that are publicly available and from MSHIP and the UMN VDL. And we see that in red, we have the cases associated with this variant. And the takeaway message here is that all of these cases are concentrated in one single cluster, showing us that this virus is different than anything we have seen historically. And then on figure B, we are actually zooming in on that clade. And what this shows us is that we have a substructure within this clade, and we appear to have pretty much like 3 main subclades within that substructure. So just to keep that in mind. Next slide, please. So then since our last presentation, we actually were able to do some whole genome sequencing for 17 cases of this variant. And we are showing this here on this phylogenetic tree color-coded by lineage. Next. So this highlighted clade over there are the clade corresponding to all of our cases, all of our lineage 1C, 144 variant cases. And again, as we saw on the R5, we can see that all of them cluster together, even if we consider the other regions of the genome, meaning that this, again, still seems to be something different than what we have been seeing historically. Next. And then if you were to look at a close-up of that clade, again, using the whole genome sequence, next, we can see pretty much the same clustering or subclading structure that we saw in R5. So we have those 3 main clades that we observed in R5 as well. So regarding those 2 aspects, we are getting the same interpretation from R5 than we are from whole genome. And probably because this is such a new virus that we're getting the same information either with R5 or whole genome. Next. And then just to finish off, I would just like to put some things here into perspective for the practitioners and veterinarians out there that might perhaps start getting a little bit confused with all of this nomenclature. So for all of our cases, we actually classified most of them as RFLPs 144s, but we also found some that would be classified as 143s and 174s. So if you see on the figure on the left, we have phylogenetic tree of lineage 1C sequences, and they are color-coded by RFLP type. And we can see that we have several RFLP types within the lineage 1C clade. So what does that mean? So if I'm someone that is sending us a sequence to the VDL, for example, and I come back and the results come back as for just lineage 1C, that information alone would give me a probability of 43% of the sequence that I sent being actually this variant. So if the only information I have is RFLP 144, then I have a probability of only 34% of being actually this variant. So if I combine both lineage and RFLP classification, then the probability goes up to 81% of both of us being talking about the same virus that is this variant, right? So this is important because if I'm talking to someone else and they say, you know, I have a RFLP 144 in my farm, what does that mean? Does this mean that I have this variant or not? We can see here the probability of having of being this particular variant according to the different classifications. And I would just like to point out that there is no standardized nomenclature for whole genome sequence variants yet. So in the previous slide, we were using lineage classification, which is actually based only on the R5 portion of the genome. So we still don't have a standardized nomenclature for the whole genome. Next. And then just to finish the presentation, just like to point out that much still remains unknown. We still need additional epidemiological investigations to fully understand the transmission of this strain. We did conduct case control studies with sequences from October to December, and we actually didn't find any specific risk factors associated with the transmission of this variant compared to the transmission of other PRRS strains. So continuous monitoring is vital to try to answer some of the questions from the industry, such as, will this variant spread to different regions and will it cause the same production impact? Because we have been hearing reports from the field that outbreaks that occurred during spring were actually a little bit milder than the ones that occurred during winter. And lastly, just to summarize once again, that variant nomenclature still needs to be standardized. We still don't have a standardized nomenclature for such a specific classification as we are using now in terms of percent identity of sequences, right? So there are several unrelated PRRS 144s and there are several unrelated PRRS lineage 1C. Next. And with that, I would like to thank once again the veterinarian and production systems for sharing all this data with us. I would like to thank the MSHIM team, particularly Catalina and Akarin, for producing most of the maps and phylogenetic trees that we saw in this presentation, and also the funding sources, Swine Health Information Center and Swine Disease Eradication Centers, and the collaborating VDLs. Next. And with that, I'll thank you all for your attention, and that's it. Thank you.
Thank you, Dr. Kikuchi. Our next presenters are Dr. Paul Yeske and Dr. Daryl Holkamp. Dr. Yeske earned his DVM from Iowa State University College of Veterinary Medicine and his Master of Science from the University of Minnesota. Dr. Yeske is currently a veterinarian at the Swine Vet Center in St. Peter, Minnesota. Dr. Daryl Holkamp is a professor in the Department of Veterinary Diagnostics and Production Animal Medicine and the College of Veterinary Medicine at Iowa State University. He received his DVM, Master of Science in Agricultural Economics, and Bachelor of Science in Agricultural Business with a minor in Statistics, all from Iowa State University. The title of their presentation is Rapid Response Teams Investigations of Pathways of Entry. Dr. Yeske and Dr. Holkamp, I'm going to turn it over to you.
Thanks, Kristen. Unfortunately, and I'd say more unfortunately for the pigs, I've had the opportunity to see this virus a number of times. Could you advance to the next slide? And so what we wanted to do for the outline this afternoon is talk just a little bit about what we've been seeing in the field, both last fall and this spring, and then go into some greater detail on some of the outbreak investigations we did here in June. So we'll follow up with that more specifically as we go forward. Next slide, please. I think we've had a good review this afternoon of why this is such a concern. You see that peak in May, which we've always seen a little peak up in May, but nothing like what we saw that actually went higher than the fall peak. And when we thought it was bad in the fall of last year with the 144, looking at what's happened this spring, where we saw that number of cases just get even higher from the Morrison Swine Health Monitoring Project. So certainly telling us we know there's a lot of virus circulating out there in the country, particularly in Iowa and Minnesota. Next slide, please. And for managing PRRS, a lot of herds have gone to the filtration. And what we saw was a number of these farms even turning positive with this new variant. And so certainly became very concerning for us. Next slide, please. And Dr. Laura Brunner and our group at the Swine Vet Center sent out, because of the number of outbreaks this spring, sent out a survey to 22 veterinarians. She got 15 responses, about 1.8 million sows in the small quick study. And next slide, please. You can see from that study that there was over a 6-week period of time, there was a number of positive herds that broke, a number of sow farm, a high number of sows, an even higher number of nursery and finishing pigs, and a lot of sites involved. Next slide, please. And asked the question of what concerns did you have from biosecurity and what was going on at the time of the outbreak. Again, it was following the manure pumping season that usually starts in that April timeframe, and then a lot of grow finish breaks regionally, and then some of the other concerns that we'd expect. So next slide, please. So from a clinical experience, the abortions is probably one of the hallmarks of this disease, particularly last fall. I would say this spring, we've seen less of a number of abortions with the outbreaks. We've seen this spring more what we'd consider in a normal, what we quote unquote, a normal PRRS break. usually somewhere between a week to a week and a half's worth of farrowing on a sow farm. And again, being more what we'd expect for an outbreak, not what we were seeing last winter. And the mortality doing somewhat the same thing as far as the number of sow mortalities, getting more back in line with what we'd expect with a typical PRRS outbreak, and a little less loss in body condition and feed intake for the extended periods of time we saw last fall. From the piglet side, however, I would say it's very similar to what we saw last fall. Still a lot of stillborns, and for a short period of time, then a lot of mummies and an extended tail of mummies. The pre-weaning mortality is going as high as 100% for a few weeks, and the piglet quality deteriorating very rapidly within the farrowing barn. So really not a big change from what we saw in the fall. And then the post-wean, again, seeing those higher mortalities in the pigs that moved on to the nursery. And so again, that's maybe a little bit better than where we were in the fall, but very similar. Next slide, please. And one of the things that was probably a little bit more unique as we got into the spring is we started seeing, we saw some of these last fall too, low CTs, but some even lower ones this spring, some numbers as low as 8, which is extremely low, and many in the low teens. Again, some numbers we just hadn't seen before. And when we looked at the quantitative numbers, up to 25,000 viruses per mil. So the serology test here telling us that we just got a lot of virus in these samples. Next slide, please. This is a homology chart for one of our clients. And the pink ones are the 1441Cs. And you can see there's a lot. And again, they're bunched in time from the bottom being the most recent. And so definitely a lot of activity. There's some others activity out there as well, but certainly a lot of that activity. And the one on the right, the clinic farms, again, this is a 98% homology chart as well. And the print is so small because there's so many to get it onto the page here. It got virtually unreadable, but I think it just tells you how much activity is going on. Next slide, please. So we'll go on into the outbreak investigation and why we wanted to do that, back to the outline, and go on to the next slide. So the first step was I'd been involved with the rapid response team and understanding that these outbreak investigations were being done, and that there's a good format to do that. And so I talked to Dr. Sundberg about would it be possible to do that on this new variant that's moving through the industry, and try and have a better understanding of that and use this as an exercise for the rapid response team. And he forwarded me on to contact Dr. Daryl Holtkamp at Iowa State to set that up to get it done on a couple of these farms that broke in the spring. Next slide, please. And so we set, there's some basic information we needed to pull together before we did the outbreak investigation, the date, some of the details on the virus. Next slide, please. The location of the site, the date of the outbreak, known sequences in the area, especially closely related sequences. And as you could see from those charts, there was a number of them. Next slide, please. And our goal, as we went out to talk to the farms, and our goal with the staff was to not necessarily assign blame to anyone in the farm or the production system, but to try and understand weaknesses that might be in the biosecurity programs, and how we could develop and get how we could work with this and try and improve that as we go forward. And we realized going in that we might not necessarily get the answer to why the break occurred, but hopefully we could identify some of the potential hazards out there and try and put better steps in to try and control those. Next slide, please.
All right, thanks, Paul. So thought I'd give you a little bit of information here then for some context about how we approach this, so you can get a better understanding of kind of what the findings we're going to present mean here. So fundamentally, what we're doing here is conducting a hazard analysis, and we do that in the context of an outbreak investigation with some additional information to work with, and that includes sequencing information, the database that Paul showed there earlier, one for the company as well as one for their entire practice, and that of course included the company. and then the timing and location of first clinical signs, and some other information as well. In this case, there were so many, because there were so many other sequences in the database that were within 99% or higher nucleotide homologies, it actually was probably less valuable to us than what it often can be. If there's only maybe a half a dozen or so of those other sites, that helps us narrow down the operational connections and kind of pinpoint specific events that may have led to the outbreak. In this case, I described it before as trying to conduct a murder investigation in the middle of a gang fight. You just have a lot of suspects, and so it's kind of difficult to sometimes narrow that down. And so at the end of the day, what we're really, the other, I guess, thing we're trying to do here is identify whether the farm is most vulnerable, sorry. And so then, as Paul mentioned, then you can target control measures then, or prioritize those based on those vulnerabilities. And so events, the slide, Kristen, please. So then need to understand then, if we're doing a hazard analysis, what do we mean by hazard? And so there's another term here that we have to describe first, and that is a failure. And failures are things that lead then to an eventual outbreak. And as it turns out, as we've thought this through, there's really a series of failures then that is required for the introduction of a pathogen into a susceptible herd. So these individual failures that I'll present on the next slide are necessary, but they're not sufficient. You need all three of them. And so the definition of a hazard then is something then, circumstance, lack of a control measure, whatever it is something that's going to lead then potentially to one of these three failures listed on this slide here. And so the first failure then is a failure to prevent viral contamination. And so that's basically a failure to prevent what we describe as a pathogen carrying agent from being either contaminated or infected with the infectious virus, in this case, pathogen in general. But by pathogen carrying agent, we mean anything that can either be contaminated or infected with the virus. And so that obviously is going to include just about anything, right? With pigs, the only natural host for PRRS virus is the pig itself. And so all the other things we worry about, people, trucks, vehicles, and so forth, are going to be potentially contaminated. The second failure then is a failure to mitigate that contamination or infection of that pathogen carrying agent if it happened. And so that may be related to, first of all, if we can, maybe sanitation, decontamination. It may be related to testing pigs or Giltzen, for example, before we bring them in. So are we doing things, or are we able to mitigate any contamination or infection if it occurs before we have that entry event occur on the farm? And then the third failure then is a failure to prevent pigs in a herd from being infected. And this would be infected by some appropriate route of entry. In the case of a pig, that's pretty much anything. It could be intranasal, it could be oral. With PRRS virus, it pretty much can infect a pig by any route of entry. And it has to be a sufficient dose, an infectious dose of the virus that gets from the pathogen carrying agent then to the pigs in the herd. And generally, we'd expect that there's going to be one pig, the index case, it's going to be infected first. It'd be unlikely that we'd have multiple pigs infected at exactly the same time, but that's past the point where we can actually detect that. So we just generally think of pigs in a herd becoming infected. Next slide. And so on this slide, I'll walk you through this. It's a little bit busy, but essentially it has the three failures here in red. And then you can see then as we walk through here how all three of these failures have to happen for at the bottom there, you see a herd is infected. So the first, what I'm going to do here is use as an example of a call sow removal as our event that happens on the farm. And then the specific pathogen carrying agent that comes with that event then is the livestock trailer. So obviously there's others, including the driver, any equipment that he has with him, and so forth. But we're going to focus for this example on the livestock trailer itself. And so the first example of the failure would be then that trailer gets contaminated with PRRS virus before it hauls our cull sows. If that doesn't happen, there's no risk. On the other hand, though, if it does, and an example of a hazard that might lead to that would be that trailer may have hauled sows from another PRRS positive sow farm before it came to get our culls. And so if that failure occurs, then the next one we got to worry about is the failure to mitigate that. And in this case, it may be the case that the measures intended to remove or inactivate the virus on the trailer fail, right? So we may have a truck wash in place, but we don't adequately decontaminate that trailer. If on the other hand, we don't fail there and we do adequately mitigate that contamination, that's the end of the story. There's no more risk. On the other hand, a hazard that would lead to that, for example, no oversight of the trailer wash. And so we may not really know, we may know in principle of what's supposed to get done there, but if we're not really paying attention or not periodically going and looking there, we may not really know what's going on. And so we may miss something there. And so that may be a hazard then that may lead to the failure then to mitigate that contamination of the trailer. And then chronologically in time, the next thing that typically happens is that trailer is going to show up at the farm, right? That comes to get the gilt or the call sows. And so that's going to happen. I've got a branch off there to know that means if we don't remove any call sows, that there's no risk there. But all these events that we think about that are potentially going to lead to the introduction of virus are things that have to happen, right? They're normal production activities. And so that's going to happen. And then the third and final failure then that has to happen for the herd to get infected is, again, that trailer, the contamination of that trailer somehow has to get from that trailer to a pig or sow in the herd and infect that pig or sow. And then that's going to lead to the outbreak then. And an example here of how that last failure or hazard that may lead to that last failure then is maybe only a single line of separation between the chute and the trailer. So that means that we treat that area essentially just behind the trailer or the end of the chute there as a clean area. And if we have people making multiple trips going back and forth to the trailer and then to the end of the chute and then back into the barn, may ultimately drag whatever contamination was on that trailer back into the barn there. All right, next slide, Kristen. All right, so to do the hazard analysis, we really just start with a review of all these production activities. So entry of semen, removal of calls, entry of employees, and so forth. And what we want to dig into those fairly deeply to understand the details of what I describe as the who, what, when, where, and how, right? And we want to know who's doing these things. We want to know how they're doing them. We want to know in the context of an outbreak investigation when they did them, because that could be valuable information. And again, where may indicate, whether the trailer in this case might have gone to a coal plant that, could have potentially been contaminated there. So really want to understand all that, the who, what, when, where, and how of all these events so that then we can better understand or get an understanding then of where those hazards might lie. Next slide. And so the form we used for this was one that we developed a while back and then adapted for the Swine Health Monitoring, the Swine Health Information Center's Rapid Response Program. And you can find this online, so you can go out. It's a Word document. It's even editable. But if you go to the SHIC's website, swinehealth.org, and you click or hover over the Emerging Diseases tab at the top there, the first thing that'll show up is the Rapid Response Program. If you click on that, you'll get to a page where towards the bottom of it, it'll have some rapid response resources that you can click on that link and it'll take you to those, including the form there. So you're welcome to check that out if you like. Next slide. And in that form, then it's organized by what we describe as carrying agent entry events or events. Here for short. And here on this slide, it's organized by swine movement events. So you got swine delivery, breeding replacement delivery, and so forth. You have deliveries and removals, people movements, other animals and insects, and then air and water are even considered entry events. Of course, those are going to occur continuously. But then as we go through the form, and the form is actually in the same order of the events listed on this page. So we try to follow that same order every time. And at the end of this, after we have kind of the report put together and have digested everything, we're going to assign a rating of low, medium, or high to each one of these events based on how likely we think that event may have contributed to the current outbreak here. And so we'll talk about in a little bit here then for the investigations we did, which ones we rated high. So next slide. All right, so we put an investigation team together, listed there. Dr. Pitkin, Dr. Corzo were joined us as rapid response core team members who were going to be conducting the investigation. I attended also as a facilitator or to kind of help guide the discussion in some way. And then Kyle Nisley, one of the interns through the swine veterinary internship program with Swine Vet Center this summer, then came along. It's always good to have some help on these, good student help on these, to take notes and then help put that report together afterwards. And so Kyle helped us out with that. The herd veterinarian in this case for both of the farms we investigated was Dr. Yeski. And then in each case, we had the farm manager for the respective farm there, as well as on the first, for the first farm, we had some production management there, as well as the director of biosecurity for this production system. Next slide. And so we'll go through here. We start kind of get an assessment of the characteristics of the site, the herd, and the surrounding area. And for that, I'll turn that back over to Paul here.
Next slide, please. You can see here when we did the comparison and looked at the homology that within the production system, we'd had a number of viruses that were within 2%. So there's many opportunities of spread within the area and many operation connections that could be to positive farms. And so, as Daryl said earlier, it certainly added to the confusion. Usually we don't find that in these investigations. And so that's why we wanted to take this more structured approach. Next slide, please. And so when we looked at it even a little tighter, down to 99% homology, we had 20 on farm one, we had 20 farms that had the similar virus in the production system, and there was 64 other sites in the SVC database. When we looked at farm two, again, narrowing that down to 99% on that particular farm virus, it was 28 within the same production system and 131 within the database. And understand that the two viruses were similar, but not identical, because they were 99.3% similar. Next slide, please. And both these farms were commercial farrow to wean sow farms, 2,500 head sow size of unit, and together part of a production system, and both were negative pressure ventilated farms. Next slide, please. This is looking at farm one and just looking at the farms within 5 miles. And so you can see certainly a fair bit of pig density. There was over 39,000 wean to finish pigs, spaces within that 5 mile radius. And when we looked at it, there was 24% of those spaces had been identified positive with the 1441C at the time that the outbreak occurred. So certainly a lot of opportunity at that farm for the virus to be in the area. Next slide, please. And this is site two. Again, a little bit different demographics here, but within 5 miles, we had over 26,000 head of wean to finish spaces, over 7,000 sows, other sows, and we had a total of about 33,000. So the overall density fairly close on the two sites. But at the time of the outbreak, there was less herds involved with the 1441C. There was only 2% of those spaces that were positive at that time. Next slide, please. And we'll go back to you, Daryl.
All right. Yeah. So when we do these investigations, the first thing we try to establish is the window of time where the virus was likely introduced into the herd. And so to do that, we sometimes rely on when they saw first clinical signs. Sometimes we rely on when they saw or confirmed the diagnostics that it was PRRS. And in this case, we kind of used a mix of both. For farm one, first clinical signs were observed on May 9th of this year. They saw some scouring and rough hair coat. Pigs just didn't look good in 2 of the farm rooms, 2 and 3. And there was a slight increase in aborts, I think, that followed that or about the same time. They went in and bled some of those pigs in those 2 farrowing rooms, came back positive on May 14th. I think that actually the samples were collected on that day, but they came back positive. And so the investigation period we established for that farm then was April 16th through May 14th. So a 4-week period of time there, 28 days between April 16th and May 14th. For the second farm, the first clinical signs were observed on May 29th. I had sows off feed in north end of the gestation barns. And then they confirmed that. Actually, the first thing they saw there was positive on routine testing by PCR. And so didn't see the clinical signs until they had gotten a positive on processing fluids there as part of the routine monitoring. And so the investigation period, then again, the 4 weeks that we established for this one was April 29th to May 27th. Next slide, Kristen. And so one of the things that we do is pretty much the first thing we do as we hit each event is try to establish how many times it happened during the 4 weeks, or in most cases, we can establish the exact dates for those events for those that have a periodic occurrence and aren't occurring all the time. But you can see here then is just kind of a quick summary of the number of times by the category of those events each of those occurred. And so you can see by far people movements are the number one there. That's made up primarily of employee entry events. That also is associated with the high number there you see for pork and food entry events. You could argue that pork and food are just carrying agents that come along with the employees, but that sometimes happens, sometimes don't. So we've always kind of considered that to be a separate entry event on its own here. And so we count those twice, but that high number there is also reflecting the very high number of employee entry events that you normally see on farms. So one employee entering each time they cross through the shower or the line of separation into the farm considered one event there. Farm 2, pretty much the same, a little bit variation in the number of events here, but basically for both of these, we had about 580 events that occurred in those 4 weeks, entry events that, again, each one of those could have potentially contributed or led to the introduction of the virus. Next. And so I'll talk briefly a few of the hazards we found for just the entry events that we rated high for each farm. Farm 1, we rated 2 events high, employee entry and removal of weaned pigs. And then for Farm 2, only removal of cull sows was rated high. Next. So what were the hazards for employee entry? Well, for Farm 1, what had happened is that they had transferred an employee from another sow farm right before the outbreak occurred here. And so just to kind of orient you here, that employee left the other sow farm on April 30th there, that's highlighted in green on the calendar. And they had a 2-night downtime that they were away from pigs. And then on Monday morning, May 3rd, they came to Farm 1 and started work in farrowing there. And the farm that they came from had a virus, a very similar virus, 99.3% nucleotide homology that was sequenced back in November of 2020. So consider that basically a very similar virus. Next slide. And then the management for the company was aware of the risk in this case, and they had paid the employee to detail their vehicle. The employee worked in farrowing, again, as I mentioned, where the first clinical signs were observed. He started there immediately. And so as you look at that, then if you think in terms of the failures and the hazards that are present there, certainly that first failure, did he get contaminated? Quite possibly he did, having come from a PRRS positive farm with a very similar virus. The last failure there, transmission, did that occur? Did he somehow transmit the virus from himself to the pigs in the herd? Well, the epidemiological evidence kind of lines up with that in this case, where he worked in farrowing, and that's where they saw the first clinical signs. So that, and certainly, it's easy to see how employees can do that because they are handling pigs, handling sows directly. And so if there is a sufficient amount of virus on the employee, it's pretty easy to see how that last failure would occur then. So that put a lot of pressure then on that second failure, right? The failure to mitigate or that mitigation step. And in this case, I wouldn't say there was, tremendous evidence that almost certainly he would have failed to mitigate it. The opposite, the employee entry on this farm was pretty good. Had a bench entry, it was pretty clean. No evidence of people sort of violating any procedures there. So it looked like they were doing things fairly well there, but again, a lot of pressure on that. Did he have any hair? Did he have any sinuses, maybe under his fingernails, and maybe just missed it, right? And so, we've had cases like this or investigations like this before where We have this, and one in particular, an employee went back and forth to a PRRS positive wean to finish site for 30 days before he managed to finally infect the sow farm he was working on as well. So he had 2 jobs there. And so day 31, his luck ran out. Did it happen in this case on the first time? Possible. We didn't call this a smoking gun. Sometimes we might do that, but there were so many other possibilities here too that we didn't really call it a smoking gun in this case. So next. On farm 2, look at some of the hazards with cull sow removal. And farm 2 had a sows removed here on, you can see on the calendar, they were removed on May 24th. First clinical signs on farm 2 were observed on May 29th, so about 5 days later. And as it just so happened too, the wean pigs went out the same chute or loadout area in this case as the wean pig, or I'm sorry, as the cull sows did. And they went out, there was 2 loads went out, 1 wean pig and 1 cull load that same day. And then the trailer and the driver that hauled the cull sows had previously hauled sows from a PRRS positive site with a 100% match. And then they also hauled them to the same cull buying station as well. Next. And the culls from both farms, both farm 1 and 2, were hauled by a third-party contractor. They were hauled directly to a cull buying station, so no transfer station. The trailers were washed and disinfected between loads. They used Synergize, but it wasn't known at what concentration or volume for how long it took them to apply it. And then trailers typically would have 3 days downtime then between loads. The issue here, that we identified, I would say, was that there was a lot of trust placed in that contractor. Not necessarily any reason to believe that that was misplaced trust. But it did lead to a situation where there was relatively minimal oversight of that third party in this case, and so that oftentimes just makes you wonder. The unknown can be a hazard, and so there had been no outside audits of trailer wash where the trailers were washed by the third party contract hauler. Next. And so the last kind of thing to cover here is the way the loadout area was designed on both of these farms was very good. Of course, because they were negative pressure filtered farms, they had loadouts that were designed, of course, to minimize the amount of air that entered the farm outside the filter banks, right? So during loading, the loadout areas were designed then to minimize that unfiltered air coming into the farm. And so the procedure they used then basically was, first of all, you had the driver was going to be on the trailer. They wore dedicated boots and overalls they donned before they got in the trailer. And then he was confined to the trailer by a line of separation between the trailer and the chute. And then there were typically in this case, 2 farm employees that used some form of stage loading. And by that, I mean, the loadout area was treated as clean until the outside door of the chute was open. So under the ideal scenario here or situation, it was what it was laid out was all the cull sows or wean pigs would be loaded into that loadout area. And then once they were there, you would close the inside door between the loadout and the hallway. And then at that point, then that would become a dirty area, and then the doors to the outside would be opened up. That was how it was designed to work. And effectively, that's the way it did. And at that point, there would be a second line of separation between the loadout area and the hallway to the barn. The problem that occurred then was there was, again, exceptions made to that rule. If there were too many calls, as I believe there were in this case, to fit in the loadout area, they would have to make 2 trips. So, once they established it as a dirty area, it sort of got reverted back to a clean area again. And same with the wean pigs. The loadout area was not washed and disinfected between loads. And so again, it was kind of bouncing back between the dirty area and then or it was a clean area, and then it was a dirty, and then back to a clean, then back to a dirty, kind of is effectively how it was being operated then under these circumstances where these exceptions occurs as they did on these loads that occurred on May 24th here. Next. And so then finally, after what was supposed to happen again, or what did happen, is that after the loads were done, in this case, both the wean pig and cull sow load, the loadout area was completely washed and disinfected. A few kind of hazards we found associated with that. Good plan again, but there was a few things that could be improved here, minor tweaks. the drain on this farm was located right at the door, or just beside the door entering the hallway. And so as they were cleaning the room with the power washer, they were blowing all that water at the door. And so they indicated that a lot of that water would end up going under the door and then ending up out in the hallway. And so, essentially efforts to try to maintain or keep that whatever's dirty in that dirty area was sort of getting obliterated there as it is blowing out that all that water into the what effectively should have been the clean side of that clean dirty line into the hallway there. The other issue there was the disinfectant. They were using intervention. They applied that at a and had intended to apply it at a much higher concentration. The effective concentration that they were applying it at was 1 to 2,000, a little over 2,000. And the issue there was they were diluting it. It was getting diluted twice. They diluted it at 1 to 16, placed it into the disinfectant tank of the power washer, and then it got diluted again at 1 to 128. And so if you multiply, do the math, it ends up being a concentration of 1 to 2,000 there. And so probably not doing too much at that level of concentration. So again, in this case, certainly opportunities for that trailer to be contaminated. Lots of questions about whether or not it was would have been effectively mitigated if it was contaminated. And then also there were certainly hazards that could have led to the virus being tracked back from the trailer into the barns. In this case, with the cull sow loads, they were going back into gestation where they saw first clinical signs here. All right, next, Kristen. All right, I'll go through this fairly quickly here. For farm one, we identified removal of weaned pigs. There were actually 3 loads that went out April 28th, 29th, and then again on May 3rd. First clinical signs again on farm one was May 9th, so about 6 days later there. The issue here was they were delivering pigs to the same nursery as another sow farm that at the time they thought was negative, but it turned out later it had gone positive. Now, one thing that made this a little bit sketchier, I guess, or made the connection a little bit weaker, was that the isolate from that other sow farm was 98.7% similar only. So certainly not identical by any stretch. But the issue here was that, again, it was how long did it take to detect that outbreak in that previous sow farm? And it took long enough to detect it that there were some fairly risky things going on here. In the meantime, and that in particular for farm one, they were sending wean pigs to the same nursery as this other farm that broke. So we put it on high for that reason. Next, Kristen. And again, these wean pigs were hauled by a third-party contractor, different from the one that hauled cull sows, but still a third-party contractor. Same kind of setup though, in terms of how the trailers were washed, oversight of that third-party trailer wash and so forth. And it had the same load-out procedures as cull sow removal too. So the same issues that we had with cull sow removal, we had here with wean pig removal as well. Next slide. And then a few other hazards, then certainly you can't rule out by any means the opportunity for area spread. Especially for farm one, I believe it was, Paul, that had a lot of other swine sites or a lot of other pigs in that same area with the same lineage 1C variant. And so, again, it's important though to remember that area spread does not mean aerosol, right? There's lots of things that could result in sort of that area spread within the immediate geographic area. Air, as well as insects, rodents, and wildlife and other domestic animals. And it is important, I think, to think about the timing of the year in this case, because it's in the summer or spring these were happening. Certainly insects could have been an issue here, whereas oftentimes we rule those out in the winter. Next. All right, and then the other thing I think that was kind of highlighted was some issues with biocontainment. In this system, shower in was required, but shower out was generally optional. And so, there were several employees where, despite the strangeness of that did not regularly shower out. And so we had that issue. And then the employee that hauled the dead pigs to a compost pile, both of these sites had composting. But the employee that did that would sometimes shower out, sometimes not, and then would basically change into their street clothes, their personal clothes and shoes, and then haul the dead pigs out, get in their vehicle and go home and then return the next day. And so from a biocontainment issue there, it's pretty easy to see how, when you get employees that are working on positive farms here, that they can go out and in many days very well could be contaminated with that virus if they go shop at the same grocery stores, attend the same church, or potentially socialize or live maybe even with somebody that lives on another farm. There's opportunities there for cross-contamination to occur, and then for that virus to get spread to the next farm. So, and then Paul, I'll turn it back over to you to talk just about the results of the feed mill audit that you did.
Yeah, we did take the opportunity because of the amount of connections and the number of viruses to go and do a feed mill audit and just to get that up to speed and take a look there. We had very good cooperation with the mill. We did identify some potential, certainly some potential contacts. In some of the testing we didn't identify any positive results, but again, there's certainly some hazards that could exist there. And so it was a good discussion with the mill and their team on what they can do to help us from a biosecurity standpoint. We also are in the process of doing some truck wash audits to go through the various phases of the different areas we talked about as far as the cull sow truck, the weaner trucks, and then some of the market trucks that would be transporting gilts, just to make it a complete package of the system to understand what's going on.
Okay, next. So Paul, I'll start with this one, but I think just some kind of key industry messages here, in that we looked at it kind of as what was the same about this, right? And I think as is always the case when we do these outbreak investigations, you're going to identify some hazards. They're just there's no way to eliminate all of those, and so we did, but that's nothing new, right? I think we see that happening. The other thing that's maybe not new here as well is opportunities for area spread that were present here. And so, Paul, I'll let you comment on the possibility that there was a failure of the filtration there, or.
Yeah, it's always hard to know, and we know there's certainly on the one farm a lot of positive pigs, very relatively close. The farms did do a very good job of doing regular inspections of the filtration equipment. So I think that one, to me, certainly is always possible, but really didn't find a lot of things going there, and it's always difficult to know for sure. If you want to go on to the next slide. So I'll let you take that one back again, Daryl.
Okay, all right. So what's different then? And I think Marianne in particular mentioned some things that look very different about this virus, and I do think it's clearly it's more virulent than the typical PRRS viruses we're used to dealing with. Even though we have to acknowledge that occasionally these do pop up where you have more severe virus or more severe outbreaks, but I think the extent to which this is real, this one causes problems, is relatively new. It also appears to be highly contagious, right? Just the sheer number of viruses, isolates that are within 99% homology in a concentrated geographic area within production systems suggests that it moves from farm to farm, is transmitted very easily. And so, describe it here as no hazard is left unpunished, right? If you've got gaps, it's going to find them. Why? That's purely speculation at this point. Is it due to the high level of viral shedding that Paul pointed out earlier? And is it possibly that it survives better in the environment, more resistant to heat, to sunlight, to chemical disinfectants? Maybe the route of entry is different, or the cells that it can be affected, or the minimum infectious dose that's required to infect pigs has changed somehow. And so again, all those things, I know there's a number of studies going on to evaluate some of those, but at this point the answer simply is we don't know. And then Paul, I'll let you address the counter seasonality of it.
Yeah, I think that's what's probably the most unique thing, and why we wanted to go in and take a look at doing these outbreak investigations. It's just was a strange time for some of these herds to break in this, not that it's impossible for a farm to break anytime, but certainly the number of farms that were breaking in the end of April, May, and into June were certainly uncommon, and we wanted to try and take a little deeper look at that. And probably the biggest concern was a little bit more concern, will the we saw the magnitude of the waves increase, and so I'm a little bit nervous about what the third wave will look like this fall. And so trying to make sure that we could shore up some of the systems and some of the procedures and some of the things we could do that we can do on the farms. There's always unknowns, and like you said, Daryl, there's always going to be hazards, but those are kind of the goal there. Next slide, please. So again, I think our greatest areas of opportunity are to know those areas of risk or those hazards, and then we got to talk about risk, and risk is really the likelihood of something that is going to carry the virus into the herd or allow for viral entry, and then just how many times we do that specific activity. And it's kind of scary when you add up the numbers, and Daryl did a nice job of going through how many times we do those things, and so it kind of is a surprise once you see those numbers. We've always thought of the filtered farms as the bubble that included the air filtration and everything else we do in biosecurity, but we know that all those things can have hazards, and we can have opportunities for the virus to get in, and again, it's always good to go back and review those. Next slide.
All right, with that, wrap it up. I want to thank Schick for funding the rapid response program here, and then again, all those that participated in the investigation, the farm managers and others, as well as Kyle Nisley, then that helped us take notes and put the report together.
Excellent. Well, really appreciate those presentations and insights and experiences. We've got a number of questions in the queue, so we're going to go ahead and jump right into those questions. Just a reminder, if you have a question, you can type that in using the Q&A tab at the bottom of the screen. If you hover your mouse down there, you'll see that. That's the best way to get into the queue. So our first question, probably for Dr. Trevisan and Dr. Kikuti, has L1C lineage been isolated in Canada or other countries? We've had a few folks check in that they haven't seen evidence of it in Canada so far, but could you tell us a little more about what you know on the international picture?
As far as I know, I don't have information about detection of this strain in Canada. And when we look for publicly available database like PubMed, we don't find any strain that is similar to this one. The closest match that we found in the beginning was at 95% similarity using the RF5 portion of this gene.
Yeah, I agree. I think we don't have, for us in MSHIP, we don't have many sequence data sets that would include sequences from abroad as well. But publicly in GeneBank, we don't have seen so far any sequence that is similar to this particular variant, although we do have lineage 1C sequences in Northern America as well. So I would say, if we're saying just lineage 1C, we likely do have some in Canada, but if we're talking about this particular variant, then so far it seems like we don't have any, at least publicly available.
All right, excellent. Our next question is, how successful have been producers with eliminating the virus, or are we far enough along to have some experiences with elimination yet?
Yeah, we have had some herds that have been able to achieve negative processing fluids and sequential negative pigs at weaning due to be wean testing negative. So it appears to be acting similar to other viruses. And certainly, just like other viruses, some herds take longer and others go faster. So it does appear that that it is following a similar pattern.
I would add that there have been probably increased incidence of depop repops, mainly because of the high sow death loss. and in some cases even combining two herds that broke with the same isolate to make one whole herd, because they lost so many sows. But I think that's probably the other thing that's maybe a little unique about this one.
Yeah, I'd agree with that. In the past, I wouldn't say that depop repop was a very common method used for virus elimination.
Yeah, normally it doesn't pay, but in this case, it sometimes it does, I guess.
All right, thank you very much for that. The next question that we have is, has the whole genome sequencing research led to any conclusions if this is a mutation or recombination, or do we have any ideas about that potentially?
Yeah, we have a separate research group investigating only the whole genome analysis. But what we know so far is that there appears to have a recombination at the NSP2 portion of the genome with a virus that would, in the R5 region, be considered an L1A virus. So we are still investigating this, and we hope to have more information soon, but it appears to have some recombinations. Yeah.
All right, thank you. The next question is, in the outbreak investigation form, is there an area for unusual events like heavy rain, drainage into the farm, windstorms, Midwest August derecho, things of that nature that might be relevant, and how do we consider those?
I'll take that one. Good to hear from you, Dr. Baker. Yeah, we do look at the weather. We find the nearest weather station and then get the every 6-hour weather for these. So we would know if any of those things had happened during the investigation period on both of these farms, and in both of these cases, nothing like that happened. We also look at the wind direction, wind speeds during that time, and that can be valuable if you have maybe just one other farm in the area that's got a similar virus. In this case, you had so many there that, believe it or not, there were many days when the wind could have been in the right direction. So practically every day, because they were just basically surrounded. So so the weather data in this case was probably not as useful as it can be in others.
All right, thank you. Anything particularly unusual noted in the non-OR5 open reading frames when you look at any of those 17 whole genome sequencing cases that have been compared? Is there anything unusual that has become evident so far?
Yeah, again, I think we still need to look a little bit more deeper into the whole genome sequences. So far, we know that there seems to be a potential recombination point in ORF2, but we still need more updates on that regard. So I don't have a good answer for you right now, but feel free to contact us later and we can get you in touch with the researchers that are conducting the analysis.
All right, thank you. Have the cases from late 2020 continued to have high virus levels in processing fluids? Have any of those herds stabilized, and is post-weaning mortality stabilized in many of the herds?
Yeah, like I said before, what we've seen is it's following the trend of many other viruses as far as the timelines, what we would expect for these. We see the processing fluids over time. We see the CT values going up. We see the piglets starting to test negative, just like we would with other viruses. And we've seen, like I said, we've already had a few herds that have already cleared what we believe to be has cleared the virus from the herd. So I think it is acting very similar on all those different avenues. And the nursery mortalities are also coming back into line too, as we get to more negative pigs out there and we push those outbreaks a little bit older pigs. We're seeing the mortality start to drop off as we get that happening.
All right. 2 more questions so far, and again, a reminder, you can enter those with the Q&A button at the bottom of the screen. Is there any evidence of this strain being more resistant to disinfectants?
I don't know if anyone is looking at this yet, right?
Yeah. I actually know there's a couple of studies being designed or put together at the moment to look at that, but I don't think there's any evidence yet to suggest that it might be more resistant to certain chemical disinfectants. If I had to place a bet, I would say the odds right now probably favor the large amount of virus theory, right? I mean, that's the one thing we probably, at least anecdotally, have some evidence to suggest that there's just a lot of this virus out there, right? When you get those really low single-digit CT values on serum samples, that suggests there's just a tremendous amount of virus there. And so at this point, it's all guessing. But again, if I had to place a bet, that's where mine would be today.
I would agree with that, yeah.
Yeah, me too.
All right. Several comments suggesting that. Really appreciate the information you shared today. One last question then. What's the next step to get some sort of standardized nomenclature? Well, what do we still need? I think we could say we always need additional research, but what's it take to get to a standardized nomenclature? Is it consensus? Is it you know, what's it going to take?
I would say we just need to sit everyone together that works with the virus and try to come up with a consensus nomenclature, particularly for whole genome, which we're now starting to generate much more information that we had in the past. So we don't have anything standardized yet. But also for this particular variant that we are using a criteria that is much finer than just lineage classification, for example, or just RFLP. So we can see that both of those classifications are not enough. I think we just need to maybe just sit everyone together and discuss how we can move forward with this, given that, you know, the diagnosis methods changed a lot in the past few years. So we need to change our nomenclature as well.
And we need to remind that there is a lot of mutations and genetic variability that occurs with PRRS, and the virus continue to evolve over time. So it's still difficult to find this correct way to classify the sequence according, have a standard nomenclature. So for sure, as you mentioned, more work needs to be done, but we need to find a way that this could overlap these issues that we already know it's facing. For example, if you look for lineage, we know that 5 to 6% of our sequence doesn't classify according to lineage. So we need to keep moving the needles there.
All right. One other question that's come in. Is there any information on the use of vaccine in the herds before they broke?
Across in the two herds we investigated, those were both category 4 herds, and so they were not vaccinating. But we have had vaccinated herds that break as well. So certainly doesn't, as we might expect, probably isn't going to be totally effective when we talk about the reproductive side of the equation.
And I would add that in our case control study, we found vaccinated herds both in the case group and in the control group. So we didn't see a difference, a statistical difference there between herds that were vaccinated and that were unvaccinated.
Yeah, a lot of information from about these herds, these outbreaks that we could have presented, but that's one we I think I probably missed, Paul. You know, both were category 4, and I think both of them had been negative for quite a long time, right? I can't remember off the top of my head. Do you remember the last time they had outbreaks in these herds?
The one herd had been about 3 years, and the other one had been long time. Yeah. I'd have to look back.
And these are both herds in relatively pig dense areas. So.
All right. I think I heard the answer to this one earlier, but I'll let you take another crack at it. Is there any evidence that this strain is a recombination of a wild virus with the modified live vaccine virus, or related to using modified live vaccines?
With our group, so far we don't have any evidence of that. Yeah, I don't think I can add any more to that. I don't think we have found any evidence for that yet. So
we do have some sequence that was done here at Iowa State University, and we didn't find any evidence of recombination with modified live vaccine as well.
All right. Considering the outbreak investigation and with so many sites in the area also positive, what features or biological barriers did or did not exist regarding feed mills or feed deliveries?
So if I understand that one correctly, Dr. Geiger, asking about what control measures they had in place there. They were, I think a lot of these shared a common feed mill, but they were scheduling deliveries based on the status of farms. So they had one of the jobs, I think, or one of the things the director of biosecurity did was to maintain I don't think they described it as a health pyramid, but some call it that, maintain that, and then they base their scheduling, including feed deliveries on that. And so, Paul, maybe you can speak a little bit more to some of the other things that they were doing with feed delivery. But
yeah, basically it was based upon the known health status at the time of that. The trucks are washed before they would re-enter that pyramid again, and so they would be cleaned before re-entering the pyramid to go back to other farms again later.
Okay, very well. Do we know yet if there have been any changes in protocols or biosecurity that are actually able to lessen the impact of the third failure, that being the transmission to pigs when the LC1 variant enters the farm or is in proximity to the farm?
mm-hmm. Yeah, nothing specific to the to the variant, L1C variant, but I'd say there has been some research done recently to look at that, especially with livestock transport. Chelsea Rustin, a grad student that worked with me, did a stage loading study a while back here, looking at the value of adding in basically a second line of separation there to create an area in the loadout where you station one person there. So they're not, essentially going up to the edge of the trailer or the end of the chute and then walking back into the barn each time. She did this with market loads, but the same would apply with wean pigs and cull sow removal. And I kind of alluded to that earlier, but the idea there is that if you have virus on that trailer, one of the things that came out of Chelsea's study was we were using the fluorescent powder, the glow germ, to do this study, and it was just astonishing to see how easy it is for that, things to get kicked off that trailer. When pigs lunge, they lunge off their back feet, and if they slip, they kick a lot of wood chips and other things back into the chute. Almost every load, the driver violated that clean, dirty line, and so did the person, bringing the pigs up there. Many, multiple occurrences of pigs getting on the trailer and turning around and coming back off again. So despite how well we think those things get done, they're just, those things happen. And so, it's really kind of interesting to see how much of that got drugged back, or at least the fluorescent powder got drugged back into the barn there. And so I think we're starting to look at some of those studies, but probably some more work to do in that area.
All right, a couple of last questions, and then we're going to have to wrap it up for to be considerate of our folks' times. Would you recommend vaccinating a herd with MLV when a new introduction of this virus happens prior to conducting LVI?
Yeah, I think that's really a decision that every farm is going to need to make on their own with their own herd veterinarian, and so I think that's a little bit hard to make as a generalized statement.
I think that's an excellent response, very case specific there, and so a lot of local values got to weigh into that decision-making process. And last question then, can anyone speak to the use of injectable ivermectin as a control measure? Have any of you been involved or experienced any attempts to use that as an intervention?
I personally do not have any experience with that, so I really can't speak to it.
Yeah, my only familiarity with it is what was presented at the meeting at the World Pork Expo there, and I think it's at this point it's fairly anecdotal, but seems like might warrant some research to see if there's something to it. But I have no direct experience with it either, Locke.
Me neither.
Right. I think with that, we're going to have to wrap things up today, but I really appreciate all the effort to compile and present the information by our speakers. Appreciate everyone attending and the great questions that we got. And with that, I'm going to turn it over to Kristen to close us out.
Thank you, Dr. Carricker. Thank you, everybody, for attending today's webinar on PRRS 144 Incidence and Response, presented by SHIC in collaboration with AASV. And thank you to our guest speakers for taking time to present their knowledge and strategies on this emerging disease. We really appreciate it. If you have questions regarding any of the information presented today, please feel free to email isusmec@iastate.edu. And we will direct your questions accordingly, or reach out to Dr. Paul Sundberg or Dr. Abby Cannon and any of our fellow speakers or myself directly. Thank you for your participation and have a great day.